guys, today we're going to learn about the division algorithm, also known as the Euclidean algorithm. Now the point or the goal of the division algorithm is to find the GCD, which is the greatest common divisor between two numbers. In other words, we want to find the largest positive integer that divides between two numbers without a remainder. So that's exactly what the division algorithm helps us find. So when working with the division algorithm, we have our A equal B times Q plus R, where A is the bigger integer, B is the smaller integer, Q is the quotient, and R is the remainder. So let's try to do the division algorithm with small numbers like 64 and 4. Okay, in this case, our A is going to be 64 because that's the bigger number between these two, and our B is going to be 4. So when doing the division algorithm, we will divide this out just like we would any number. So our bigger number will go inside the box, and the smaller number will follow. Now, we want to know how many times does 4 go into 64? Well, 4 goes into 64 at least 16 times, exactly 16 times, with no remainder at all. So now we find that our quotient is 16 and our remainder is 0. Now to properly do the division algorithm, we have to make sure we go back to this formula by inputting the numbers we just found. So our A is 64 equals B, which B we found that it was 4, and our quotient we found that it was 16. Now our remainder is 0, so we can choose to write it in or not, but either way it's not going to affect the answer. So I'm going to write it down so you guys can see it. So what this is saying is that 4 times 16 equals 64. So in this case, 4 was the number that gave us, the divisor that gave us 0 is 4. So when working with the division algorithm, the number or the divisor that gives you 0, the remainder of 0, is your GCF. So between 64 and 4, your GCD, your greatest common divisor is 4. Now let's do a bigger number like 515. Let's do a number like 515 and 30. Well, between 515 and 30, between 515 and 30, 515 is the bigger number, so that's the number that will go inside the box. So 515 is our A and our 30 is our B, because 515 is the bigger number and 30 is the smaller number, so this would be B. So we will divide just like we would any number. So we want to know how many times does 30 go into 515? Well, 30 goes into 515 at least 17 times. But not quite, because 30 times 17 is actually 510, which means we end up with a remainder of 5. Now, we still don't have a remainder of 0, which means we're going to have to keep working until we get 0. But how? Well, when working with the division algorithm, once we find our answers of the division, we really just care about our divisor and our remainder. So everything else kind of doesn't matter. So what I do is I just kind of cross all that stuff out. And remember, we only care about divisor and our remainder. So now we have 30 and 5. So now let's put 30 and 5 in terms of the division algorithm formula. So we know that our A is 30 because that's the bigger number. And our B is 5 because that's the smaller number. So now let's divide this out like we would any number. So let's not forget that 30 goes inside the box, is the bigger number. And then 5 goes outside the box. Oh, I just confused myself. Okay, so this is actually supposed to be orange. And our 5, our B is going to be green. So we want to know how many times does 5 go into 30? Well, we know that 5 goes into 30 6 times exactly. So that's our quotient. So 6 times 5 is 30 with a remainder of 0. Okay, so we finally found our GCD, our greatest common divisor. Now let's not forget that let's not forget to write what we found in terms of the formula, which again is A equals B times Q plus R. Okay, so that first part that we were working, we found that our A was 515. Our B was 30. Our quotient was 17. And our remainder was 5. And indeed, 30 times 17 plus 5 is 515. Now let's not forget about the second part that we also found. We said that our A in that part was 30. Our B was 5. Our quotient was 6. And our remainder was 0. And indeed, 5 times 6 equals 30. So when working with the division algorithm, the first step is to kind of identify what are our A's and B's. Once we have that, we can divide out until we find our quotient and or remainder. But don't forget to also write it out in terms of the formula. Okay. Okay, now let's do one more. Okay, we're gonna do one more. Okay, so now let's do one more. And I'm just gonna rewrite the formula so we don't forget. Okay, now let's do a number that's even bigger. Like, 4,000 or 40,210 and 100. So let's find the GCD of these two numbers. So okay, now we're gonna do one more. So we have our formula written, and we're gonna do 40,210 and 100. So we're gonna divide those two numbers just like we would any number. Okay, so we want to know how many times does 100 go into. Okay, so now we're gonna do it just like we would. Okay, so now we're dividing this just like we would any number. So we have 40,210 divided by 100. So we want to know, well, how many times does 100 go into 402 and 10? 210. And it's at least 400 times. So our quotient will be 400. So now we do 100 times 400, and that gives us 40,000, I'm sorry. And we end up with a remainder of 210. I don't like that part. Okay, guys. All right, so now let's do one more. Okay, so let's say we want to find the GCD of 4,210 and 100. So let's write our formula up again. Let's write it down again. Okay, so we would divide this just like we would normally. Oops. Okay, so we want to know how many times does 100 go into 40,210. And we can say about 402 times because 402 times 100 will give us about 40,200. So we can say about 402. So when we multiply these two, we get okay. So now we end up with 10. We end up with a remainder of 10. So now we want to get a remainder of 0, right? So like I said, we can just cross that out. And now we know that we have 100 and we have 10. So let's put those in terms of our A equals B times Q plus R. So in this part, our A is going to be 100 and our B is going to be 10. So now let's divide these up. Let's divide those up. So we know that 10 goes into 100 exactly 10 times with no remainder.